to immediately propagate it directly to the use rather than going through every block. Data flow analysis goes through every block. Okay, even the fastest data flow analysis has to go through every block. So that means with SSA edges, as we said, practical program numbers are less and you are directly jumping from def to use. Otherwise you are doing the same thing. You are computing the expression, checking whether it is constant or not. If it is constant, you mark it constant, propagate the information further. If it is not constant, newly discovered not constant, propagate the information further. All this propagation is happening along SSA edges, and that's why we are hoping that there will be less work required given there are fewer edges. Okay. But the class of discovered constants is going to be exactly the same. If I say x is constant in first algorithm, I will say x is constant in second algorithm, unless I make some mistake. If I say x is not constant in first algorithm, I will say x is not constant in second algorithm. It's only efficiency that differs. Now we will come to a different algorithm which is better in terms of efficiency as well as in terms of discovering extra constants. So the constant discovered by sparse conditional constant propagation, SCCP, will always be greater than or equal to simple constant propagation, or just CP, data flow based constant propagation. Okay, it cannot be less, it will be either same or more. And most of the time, if you have dead code in your program, unreachable code in your program, this will discover more constants. Okay, so let's look at how this works. And as I said, the idea is very simple. We have to ignore things which is happening on dead branches. How do we ignore it? Remember, your branches impact merge points. Okay, any branch will finally merge at some point. At this merge point, we have to take care of branches which are not executable or edges which are not dead. How do we do that? We only select those values which are coming along executable paths. Okay. Now again, initially we don't know. See, finally, whether a